Every pipe stress problem is a beautiful battle between two sides. You've got the primary loads, which are driven by forces. You've got the secondary loads that are driven by displacements. And to solve and to resist the primary loads, the force-driven ones, you've got to grab that pipe and hold it down and make sure it doesn't move.
And create secondary loads.
Then the secondary loads, to make them go away, you've got to let the pipe move freely. So how do you balance this? So every problem, to me, became this amazing battle to find the balance, the solution. So it's like epic sagas, like Hector versus Achilles, except in Hector versus Achilles, one of them has to die, so half the readers are very sad. And for pipe stress, you want both to come out winners all the time.
What do you get when an old school structural engineer starts thinking like a startup founder? You get Tom Van Laan, a veteran of Bechtel and CoAID, the makers of Caesar pipe stress analysis. As the founder of CloudCalc, Tom is helping engineers collaborate from anywhere in the world using software built specifically for the realities of modern infrastructure. We'll talk about his journey from drafting tables to digital platforms, the resistance to change in engineering culture, and why the next generation of structural analysis tools won't be tied to a desktop. If you're curious about innovation in a legacy industry, stick around. Tom.
Yes, Rakesh.
Welcome.
That was quite an introduction you gave me.
You're a lot more than that introduction. No, it's great to have you here. Thank you for agreeing to be interviewed. I don't think you've done a lot of interviews at this stage after you exited CoAID, and so I'm really excited about hearing your stories.
I've done a few more interviews than you might suspect. I took a left turn after leaving CoAID, and I've done a whole lot of other things, and I'm super busy and super involved. But before we go on, like I mentioned, that was a great introduction, and you've been interviewing the key exciting people in the piping field. But I'm thinking if we're looking for the most fascinating man in piping, it's right there. Next time you ought to be in this chair.
Sounds good. Yeah, we'll figure out. Actually, with AI, I could interview myself. It's now a thing. I think yes. Reid Hoffman, the CEO of LinkedIn, or the founder of LinkedIn, created an AI version of himself and proceeded to interview himself.
That could either go really well or really badly. Well, let's see how this one goes.
Let's see how this goes. Yes. We know each other in certain contexts. We've been startup investors together.
We know each other in several contexts. In fact, originally I thought you were just piping technology. And then later I found out, much later after I delved into the Houston startup scene and the tech scene, I found out your Snapstream as well. And then a whole bunch of other facets. But enough about you. Let's talk about me.
Yeah, there you go. Tell us, let's start at the beginning. Okay. I would love to have the audience just hear about your origin story. How did where did you start your career, your professional life?
I think I got into pipe stress, I think the way a lot of people did. There was no way to study. In my day, there was no way to study and learn and say, I want to be a pipe stress person. You had to sort of do it by accident. So I went to MIT. I majored in structural engineering. And I came out and I was offered a job at Bechtel Power Corporation in Maryland. And I went down there. They'd offered me a job as a civil engineer. And I got there and showed up. And they said, we don't really have any seats available right now. What do you say you go sit in the piping area for a while? You work on pipe supports and you work in piping. And I got over there and I learned probably two things pretty quickly. One, I learned that pipe stress guys made about twice as much money as civil guys. And I was hired, I was making $7.50 an hour, straight A kid out of MIT as engineer.
$7.50.
$7.50. Yeah, so I was making $15,600 a year. And the pipe stress guys were making $14. And for a long time, my only goal in life, the only thing on my bucket list was to get up to $14 an hour in my pay. So it was interesting. So that was the first thing. I realized that that it would make sense if I could try to get in that industry and stay there. Second thing I learned is that there were these amazing things, computers that could do analyses. The problem was they were super expensive. So if you're going to do a pipe stress analysis, the going rate at that time was $3 per pipe per load case. So if you had 5 load cases, okay, spring hanger design and operating, sustained, and expansion, 5 load cases. If you had 100 piping components in your analysis, that's $1,500. And you've got a straight A MIT kid here making $300 a week. So it was much more economically efficient for them to have me cranking away manual calculations for 4 weeks on something that could run and calculate and be analyzed super fast.
Well, and let's place ourselves in time here. What was?
Do we have to do that? Okay.
So I mean,
graduated in 1978.
What were the computing tools? Like
there were none.
There are no personal computers at this point.
Well, they may have come out, but they were just coming out at the time. So things were just starting to appear on the scene. And that's sort of what triggered me. And I thought it would be great if we could put these tools that are currently on the mainframe on the PCs. Then we could run these things for free, and it could free up weeks and weeks and weeks of my time.
Yeah, for free meaning, on the mainframes, you were paying per hour of compute time.
No, we were paying
per minute.
$3 a pipe times load cases. That's the way the pricing worked.
Was that a software license cost or was that a compute cost?
That was not the compute cost. That was typically what happened. For example, Dynaflex, which was one of the big software programs at the time.
Who we're going to talk
about. That was
about.
Their billing computer center was charging $1 per pipe per load case. And then Dynaflex, as their royalty, was doubling that.
Got it. Yes.
So the cost was, if you owned the software, then you'd be paying computing time.
Sure.
And probably Bechtel owned a number of them. But it was still super expensive and it's much more worthwhile for me to work. So I started thinking, these PCs are coming out. They weren't called PCs yet. These personal computers, I think the Sinclair hadn't come out yet. But I think the Apple had come out. And I started thinking, why can't we put these on the personal computer and see what happens? So at the time, I bought this thing. It's called HP85. It's Hewlett Packard's entry. And the reason I bought it is because you didn't have to buy add-on components. It had a screen, it had a keyboard, it had a magnetic tape for storage, it had a printer, a thermal printer. So I had the whole thing there. In fact, it looked like your typewriter over here.
How did you learn pipe stress? It sounds like that happened at Bechtel because they ran out of space in structural, and you ended up with a desk in the piping department.
Okay.
But who taught you? Did you have an apprenticeship or?
So I was at Bechtel and I was doing pipe supports, right? And the guys across from me are doing the pipe stress. And they sort of have a little rank over the pipe support guys. So then I got hired at Ebasco in the pipe support department, and they were just starting this. At the time, Bechtel and Ebasco were the two biggest EPCs in the world, and they were constantly, I think, Bechtel was number one for a while, and then Ebasco for 2 years, et cetera, et cetera. So they were doing all these, it was nuclear business back then. They were doing all these nuclear plants. Ebasco did not have a pipe support department. They were farming out the work to Bergen-Patterson at the time.
Oh, okay.
And so they decided that they need to get in on this, and they started forming a company from scratch. But think of this, they're number one in engineering at the time. So it's like designing and building a car while it's going 100 miles an hour down the highway. So they're trying to get all this stuff together. They're trying to get procedures. They're trying to get work out. They're trying to, they're hiring people all the time. They're trying to integrate things. So I mentioned Bechtel was very, very rigid in what they did. And because of that, they stuck to their process. They promoted people according to a schedule. You weren't allowed to get out of your seat until you'd been there 2 years in grade, things like that. So they turned out great, great work. And I've always said if I was going to build a plant, I'd go with them. But Ebasco, in the meantime, was trying to get things going and organized. So they were very good to recognize talent. They recognized what I could do, even though I was super young. And I gotta say, they pretty much bent over backwards for me. I told you they upped my pay 170% in 19 months. I wanted a promotion because I was doing all this work over the other people. And at Bechtel, it was, no, you can't have a promotion until you've done 5 years. Basco had the same rule too. They said, we really can't do it. We can't break it. So what they do, they created a new title. You're supposed to go from assistant engineer to engineer in 5 years. They told me, we just created associate engineer just so we can promote you and give you a raise. They did things like They sent me to Germany as the technical liaison on a massive piping and pipe support contract at Mannesmann in Düsseldorf. They, sent me out on the field sites and things like this. And at one point I said, I'd really like to get into pipe stress. They said, okay, done. And nobody was transferring that way. So they moved me into pipe stress. And I understood a bit because I've been doing pipe supports. I mean, it's very tangential. It's right there. It's touching. And so I moved into the pipe stress area. And I'm working and I'm doing this stuff, and it's fun. It's more interesting. But I started asking questions. Yeah, I had a mentor. So I asked my mentor, I said, this is weird. How can we separate these loads? How can we analyze it for thermal separately than weight and pressure and stuff? I mean, they're all there at the same time. Why do we run different load cases? And his answer is, I don't know. We just have to because the code says so. Just do it. And I'm there. That doesn't sit well with me. It just didn't seem right because I came from a structural thing where you put all the loads that are there on a building or a structure, or a steel frame. You do it, you check it for all of them at the same time. So I decided I was going to investigate, and I just devoured every single piece of material that I could find about pipe stress. So I read the whole Kellogg book, all the Markle papers, everything. And I realized that this is it's a beautiful battle between, I don't want to say good and evil, but it's every pipe stress problem is a beautiful battle between two sides. You've got the primary loads, which are driven by forces. You've got the secondary loads that are driven by displacements. And to solve and to resist the primary loads, the force-driven ones, you've got to grab that pipe and hold it down and make sure it doesn't move.
Right.
And to create
secondary loads.
And then the secondary loads, to make them go away, you got to let the pipe move freely. So how do you balance this? So every problem to me became this amazing battle to find the balance, the solution. So it's like, it's like an epic saga. It's, like Hector versus Achilles, except in Hector versus Achilles, one of them has to die, so half the readers are very sad going out. And for pipe stress, you want both to come out winners all the time.
Right.
And to me, this just became an amazing story that I had basically discovered by reading all this stuff myself that had to be told. So I sort of became an evangelist for this sort of thing. I went out, I actually ended up teaching pipe stress at night among all my other projects. And at the time, it was, the industry was so hot. If you came off the boat, an immigrant came off the boat and you could say the word pipe stress in English or pipe support, you got hired.
Right.
So
take my money.
Yeah. So I was doing, I was teaching this stuff at a, what do you call it? Continuing education thing, pipe stress. And I put together course notes and things like that. I had to do course notes. And that basically evolved and became the basis for the book.
For someone who might be watching this, who is who's not in piping, is unfamiliar with pipe stress, give the explanation you would give to my 12-year-old of what pipe stress is.
Wow, your 12-year-old's too smart for this. No. Okay, pipe stress. It's like I said, a piping system has got it's got a number of loads on it. It's got pressure. It's got the weight. It's got to support itself. It might
the pipe itself has weight.
Yeah, the pipe has weight. The fluid has weight. The insulation has weight. There may be wind blowing on this. There might be earthquake. There might be fluid hammer when you hear, you turn off your faucet too quickly and you hear knock, knock, knock in your pipes. That sort of thing happens in process piping, large piping as well. And then at the same time, all of this pipe is usually very hot. So when it's hot, it grows. And if we've restrained it at both ends, if it's connected to something, which it better be, it's gonna try to move, but it can't. So it's gonna bend there. So we've got all these different loads, and we want to make sure that the pipe doesn't blow up, break. We also have the ones that are there all the time. We have the ones that are cyclic. So if you heat up this process once a day, then 365 times a year, you go through this load cycle. And you know what happens if you take when I used to teach these, I always had my pointers and I'd end up breaking the pointer halfway through because I'm demonstrating fatigue loading.
Yeah.
And, so you've got different types of loadings. You've got different types of solutions. You got different types of failure modes. You've got different types of allowables, and it's really interesting. I mean, the piping codes have been around a long time, and to look at them on the surface, you might say, I don't get why they do this. But once you dig underneath, you find out there's a whole lot of logic to it, and it's really interesting. And to me, it became an absolutely beautiful thing about how you can solve and balance this. That I always say, a solution to one will cause problems in the other. A solution to primary will cause problems in secondary, and vice versa. So you got to find this beautiful solution in between, the balance. And that's what really hooked me on this stuff. And since then, and I hate to say that, I mean, I'm doing this 45 years later. I thought I got away from it for a couple of years, but.
And you still think it's beautiful.
Oh yeah, absolutely. I mean, it's amazing. It's, to me, it's, it's really something I enjoy doing.
So we're an early software entrepreneur in the piping industry.
Yeah. Yeah.
What can you tell us about your buyer? Like and who, or I think will be in the audience of this podcast. Like or this video, what did you learn about the people who buy Caesar and buy stress analysis software?
It was actually interesting. And I've got to say that Caesar too, and under Rex and Tony especially, really changed the market for that. And because originally engineers are slow to change. And I want to say they were the last to go from the mainframe to the PC. When I was working at Ebasco, everybody had a PC. The project managers, the secretaries, the drafters, the everything, except the engineers were not allowed to have it. And we actually, on my project, we ended up buying one. We called it an electronic filing system. And we ended up buying it because you weren't allowed to, because it was assumed that, well, it can't be powerful enough. It can't be right. We've always done it this way, mainframe. So up until 85, 87, 88, the buyers of pipe stress were people who could get to one of these, online computer, the Boeings, the UCS, the UCC. And to do that, you needed a very good phone line, et cetera. So you had to basically be connected to one of these computer centers.
Got it.
With a very good high-speed phone line, which means that who could run these things? People in Western countries that are very well developed. Okay, so something that I realized, I'll say one of my proudest moments at COAID, is I was in Indonesia. I was in Kalimantan, Borneo. I was in the jungle. I was at this LNG plant. And I'd gone there to do a training session, a 2-week training session. Actually, it was 11 days straight. We doubled up. There were 5 people, 5 days for one group and then 5 days for another group. Or actually, we had morning and afternoon. So all those guys were in there for 11 straight days. And I was in 11 straight days, full day. And which sounded like I just complained, but I didn't. I loved going around and meeting our customers and saying, what do you need? How do you do this? Actually see what they did. And then I tried to get out to all of our major markets at least once every 2 years. And I'd go back and say, hey, you in the front row, remember I was here last time and you asked for this? Look, bing, it's here. But anyway, so I'm there and this place is in the middle of nowhere.
The jungle.
It's in the jungle. It's a jungle. Across the street was a orangutan rehabilitation place. That was thing to do. So when I had an hour off, we went over there and I've got a great picture of me with an ape hanging on my shoulder. But anyway, so I'm over there. I show up. It's 48 hours to get there. And I show up and I'm off the plane and I'm a bit groggy and we go in and they say, we're going to have a celebration to mark the start of the class. So we get in, they get all the people from the plant there, the whole big assembly, and I'm sitting on the stage and the general manager of the stage of the plant gets up there and he says, I'm going to say a few words and then Mr. Van Laan is going to give his speech. And I'm there, wait, I was groggy, but speech? And I'm thinking, what in the world am I going to say? I can't start my class. And I start saying, well, why am I here anyway? And what? And I look out there and I see all these engineers, eager engineers. They've gone to college, they've studied engineering. And I realized that 5 years ago, they could not be doing pipe stress. There are only 3 phone lines going off of the island. So I realized that 5 years ago, these people would have had no access to engineering tools. So what we were doing was we were democratizing engineering. We were bringing, these people were as good at engineers as anyone, and now we were providing them with the same tools as everybody else. So I went up there and I gave this eloquent speech about how we were democratizing engineering, and now the entire world had access to anything that was previously inaccessible and whatever. Anyway, and I really realized that that's what we were doing at CoAid. We were bringing it to the world, to places that could only dream or had never heard of these things before. And that's literally what we did. I mentioned we had customers in 85 countries. Currently, I've been to 106 countries, and I think most of them were through business
CoAid
trips, through
customers,
CoAid. And it was great going out and see what everybody was doing wherever. And we were, standardizing the practice throughout the world. And it was really a revolution in how those things were done.
Any of those relationships that you formed when you were traveling, to every CoAid customer country once every 2 years, did they endure beyond?
Yeah, some of them did. I
CoAid?
haven't had a chance to go out and revisit some of those people and things like that, but there's still some people I keep in touch with. And I've got to say, I feel a little bit guilty about this, is that when that part of my life ended, it sort of ended because after the acquisition of CoAid, I stuck around 18 months and then I left, and my feeling was that, I've been doing this now for 33 years. I've got to find a new life. I got to do something new. And I did. I actually, when I retired, and I made my list of things I was going to do to keep myself busy. And for years, being buried in CoAid and working on that stuff, I always said, I want to know something about the tech world in Houston. I want to get involved in the tech world. I came out and I looked around and I found they were just starting a tech accelerator for startup companies. It's called Surge Accelerator.
Right.
And they had 10 startup companies in, and they were looking for investors and mentors. So I became an investor, and more importantly, I became a mentor. And because I don't do things halfway, I dove in and I started working with those companies 20 some hours a week because they needed help, whatever. I was happy to do it. I got a lot more out of my helping them than vice versa, because most of those I invested in, they've gone under.
Yeah.
They didn't work out.
Like the median startup.
Yeah. Typical. But what I realized is I say, wait a minute, there's a whole new way to work in this. For 30 some years, I've been working in software, but it's PCs, it's very siloed applications. And everybody there was working off internet-based stuff, cloud-based stuff. And I realized, I started thinking, they're doing this. Everything that they're doing is based on what? Collaboration, right? Mm-hmm. Okay, Google Docs. Okay, everything's like that now. It's based on, mobile devices. You run it on your phone and your iPad and stuff like that. You don't sit there on a siloed PC.
Yeah.
You can add and drop licenses. Spotify add a license in 15 seconds. I don't want it anymore. I drop it. In the old pipe stress world, it was perpetual licenses. You had to make a decision. Do I need this? Because you were anchored to this license for the rest of time.
Sure.
And then things about updates. If you're using this on the cloud, things would always be up to date. You're always using the up-to-date things. And so I started thinking back about the customers at CoAid. And like I said, I traveled around. I met a lot of them. And I'd always say, what do you want? What do you need? And we tried to deliver everything they wanted, but there were some things that were out of our possibility. One, they said, we'd like to be able to collaborate. We've got people and engineers in the main office. We got them off-site, in the offshore office. We got them on site. We've got clients that want to review stuff. We'd like a way to collaborate. They also said we'd like a way to manage our licenses better. As the project workload goes like this, we can add and drop licenses. They said, I was an old site engineer, and if I went out on the site and they said we can't build it this way, I'd have to pull out a scrap of paper and sketch something and then go back in and run it on the mainframe. Sure. And da-da-da-da. And what if you could actually pull up an iPad or a phone and review the calculation, or even make changes and do what ifs and things like that. And then, of course, they wanted, there were companies that were saying, we haven't updated to the newest version of Caesar 2. We're 2.5 years or 3 years late. Sure. Because we'd have to shut down the whole company. We'd have to switch everybody over. We'd have to da-da-da. And suddenly I saw that all this stuff that just seemed totally out of the possibility in the past was the way that everybody else was doing things.
Right.
So everything else we did was based on the cloud and collaboration and mobile devices and
Smartphone in
add
your
drop.
pocket.
Yeah, and da. And I said, why can't engineers have nice things too? And I started thinking about this, and I started developing it. Just so I didn't know.
It was like another, computing shift that you had witnessed as well.
Yeah,
right?
because I saw
mainframes
from
to personal-
mainframe to PCs, and that was a big change for
PC
engineers.
to mobile, internet, cloud software, right?
So I thought I didn't have any experience doing this. I'd always developed on the PC and this and that. So I bought my book, HTML for Dummies.
Nice.
And it's got 8 chapters, and it's got HTML, it's got CSS, it's got JavaScript. And I said, okay, I went through it. It's 600 some pages. It's a nice sized book. And I went through and I ran all those examples and everything. And I said, okay, I'm ready. And I talked to a few people about it, and they said, oh, it'll never work. It's too slow. You won't be able to do big jobs. You won't be able to this and that.
Even like, engineering graphics.
Yeah,
in
you won't be able to do engineering graphics or anything like that.
Yeah.
They said it just can't be done. And I thought, I'm the guy who decided I was going to run a marathon when I'd never run. I'm the guy who decided I was going to climb Kilimanjaro when I'd never stepped outdoors in my life. And I said, you say you can't do this. Okay, let's see what we can do. So I actually started working on it. And I remember you came up to me. You were at Surge Accelerator one day, because you're very big in the startup industry. And you said to me, hey, how come nobody has ever thought about developing a pipe stress program or a structural program on the cloud? And I said, just wait.
Yeah.
Just wait. And I think 2 or 3 months later, I came and I showed you my first version of the software. And I initially started with structural. And I did the structural software for a while. And then after a number of years, developed the pipe stress version too.
Right, which is CloudCalc.
Yeah, they're both called CloudCalc structural, CloudCalc. Yeah, CloudCalc pipe stress. Yep.
What did you learn from CloudCalc? It's you went out, you I think you probably broke some new ground as far as building engineering software in the cloud. What were the learnings as you went out to build that and also go out to market?
Yeah, well, going to market, building it was interesting, and because I had to, the way we do this stuff, we call it the MVP, minimum viable product, and then we start looking for things that need to be enhanced. So I'd send Actually, I decided originally, think of when this is, it's 2014, 2015, and back then, businesses were evaluated, even startups were evaluated differently than they are today. Now today, it's how many customers do you have, what's your revenue, how quickly are you going to get to profitability, how quickly can you scale? And back then, it was how many eyeballs do you have, how many people are looking at this, using it, whatever. So I decided that first, in order to get this MVP and the rapid iteration and feedback, I was going to give this away for free, and go ahead, sign up, and give me your feedback, and I'd do that. So I put out the product, and I was getting feedback from the marketplace. We're coming out with an update every month at least, and it was quick because the architecture we didn't have this legacy code that we're stuck with that made it hard to add things and change things. So we're developing this stuff really fast. So some of the things would be, well, we need it to do a certain type of loading. We need this or that. I remember I had a user who was doing a building, I think it was in Chicago. It had 2,000 members, and the internet connection was timing out while he's trying to run. And it's like, okay, this is a new problem. How do we solve this?
Sure.
So these were the interesting challenges. Adding a new feature wasn't interesting challenge, but going back and saying, how do you optimize this in something that I've never done before and that maybe other people haven't? So it became a thing about, okay, I don't need all the data down on the computer at once. I need to anticipate what he's going to be looking at first. I start dumping the data down in batches and also sending it up. I send it up in batches. So I send it up in tiny, tiny, tiny micro capsules. So I've been all over the world. I went to Cuba, which has a basically zero internet system, and I ran the product there, and it was just as fast as anywhere else. I went to Kyrgyzstan, which doesn't have it. Everywhere I'd go, I'd run this thing. But anyway, so it was interesting.
And by the way,
solving a lot of problems that
Yeah, one of the old
Didn't think
problems
about.
is like people resistant to change.
That's the other problem. I was going to say, these are the easy problems, the technical problems.
Right,
And
right,
eventually
right. Solvable.
yeah. So I think eventually I had 5,000 registered users in 120 countries and things like that. And anyway, so yeah, you mentioned the resistant to change. So I went and showed this to a lot of engineers, a lot of companies, a lot of the big companies, the ones that you'd naturally target. I'd show it and they loved what it could do. And I'd demo the stuff, and it would be, I'd come in with a PC, I'd build a model in front of them, and then I'd say, okay, let's go build it, let's run it, let's solve these problems here. I had intelligent auto loops and things built into it, and let's solve it. And now let's say, okay, you're a guy in the field. I'd pick up the iPad and say, now you're out in the field, and boom, you go to build this, and oh, they can't build this here. And I go, boom, 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 make a change here, and then change it. And then I show it's back on the original PC with all the changes and things. And then I'd say, oh, by the way, you want to play around with this? And they said, what do you mean? And I'd suddenly email them a link whereby they click on the link. And even though they don't have a CloudCalc license, they could get into CloudCalc and review, couldn't make changes, but could review everything that we had just done with all the results and query everything. And I'm saying, look at this here. You can now collaborate between all your offices, your on-site people. They can make changes. They can do what ifs and make changes instantly. You can send a link to your client who doesn't even need a copy, and he can review everything you did. And they said, that's amazing. We want it. And I said, you got it. And I was selling this very inexpensively. And it's like, it's yours for $500 a month or $50 a month or whatever it was. And they'd say, well, we can't do that. Because why? And some of them would say the cloud, and others would say because we're a Caesar 2 house, or a STAD house.
Client
requirements. Anyway, and I understand that because they put a big investment into their process, and suddenly
and they trust the calculations.
They trust the calculations. Right? They put a big investment into the process, and if they were going to change that process, you have to make another big investment, and then it's risky. And engineers, the number one thing about engineers, for good reason, they don't want to take a lot of risk. Sure. Okay, I mean they don't want.
I mean the job is risk mitigation.
The job, exactly. Yeah. So I mean I understand where this went from. So I got to say that people loved what I did. There wasn't a lot of uptake. What I'd get mostly is small guy. It ended up being smaller outfits who are like, wow, this is a super easy thing to pick up. I use it when I need it. I drop it. And so I had a bunch of little guys using this stuff, and they'd pop in and here back, every couple of months be back in, and they'd be running things and stuff like that. And, I thought, well, that's nice too. It's a very easy to use, user-friendly, full-featured product. Engineers still haven't embraced those things that I thought, that they embrace in every other phase of their life. So let's say here, slow uptake, right? Right now.
Yeah, and I suppose I don't know how big the market is for I mean, you do, I'd imagine, but have the structural engineering software packages moved to the cloud?
No, typically no.
And same with pipe stress.
Yeah,
they're
exactly.
Still all locally hosted.
You know what they did actually? A big is very ironic because one of the big arguments often was, well, if it's on the cloud, what if I don't have an internet connection? I'd say the odds of you not having an internet connection is a lot less likely than the odds that you're not in your office with your PC. I mean, you're going to be able to use it more. But now a lot of these companies have come out with the licensing over the internet. So you need to hit the license over the internet. So you still need your internet connection, but then you still need your siloed PC too. So it's fine. Anyway, my goal is that one day, this is going to be the way that everyone works. Whether it's me making bucks on it or not, doesn't matter to me. But
so you don't think there's the chances are slim, you think, or what do you think the chances are that, for example, Caesar 2 ends up being ported to cloud-based software?
Well, anything's possible, but let's look at what all these products were. They were based on. There was a product called SAP 4 back in 1972 or whatever. It came out of Berkeley. It was paid for by U.S. government, and so it's in the public domain. So a lot of these products written in Fortran, a lot of these products were basically front end and back end processors put on that software.
SAP 4.
Yeah. So if you look, I don't want to speak for all of them. And, I haven't been involved with other companies much in the last 10 years, but at the time they were all Fortran based. And Fortran does not travel very well to the cloud. So when I wrote CloudCalc, it was all from scratch in new languages, whatever it took. The number cruncher is written from scratch in C because all of these web-based products are very C-like. So whatever I had to go to in the future would be an easy morph and easy port. Sure. But these things are written in Fortran, which aren't very cloud-friendly. So I think that it would take a total rewrite of the calculational engine to go to the cloud. And I know that some of them have, but they've done it by, they put the Fortran-based product on a virtual machine somewhere, and you can log into a virtual machine and do it. But that's not the same thing.
I mean, who even has the engineering knowledge to go muck around with that Fortran code or, confidently, write it in another language? Yeah,
I think, people who've been working on it, like the people at CoAid was acquired by Intergraph, now Hexagon. The people have been working on it there. They obviously have the knowledge to, as you say, go muck around on it because they've been updating and maintaining this.
Probably not that core Fortran.
Probably not that much, but
you don't have any knowledge.
I don't have any knowledge of that. But what I'm saying, to take that and convert that to a different language is just very risky. And engineers, again, as we said, the engineers.
That's the black box.
Yeah.
Right.
Do not want to
mess around with the black box.
Mess around with that. So, what I said to them is back then, I said, if you're stuck with if you define yourself as a Caesar 2 house, a Stad house, or whatever, I don't like to say never. I said, but they're never going to get there. They're never going to get these features. I think I said a while back, Bechtel and Ebasco were very different experiences. Bechtel was not a risk taker. They were very tied to their process. They were very rigid in everything they did. And because of that, everything was turned out pretty much identically. There was a Bechtel stamp to something.
Yeah.
There's a lot of good in that because you knew their answers were right. And Ebasco was, at the time, was a little bit more like the Wild West. There was a lot of
variation and
change going on and things bubbling to the top and bottom. And to me, that was a great opportunity to work and learn in. I got millions of opportunities I never would have gotten elsewhere and things like that. But what happened there is they were flexible enough to recognize talent and take advantage of it. Yeah. And I think you need a combination of these two. I'm not going to say one's the better. You want the rightness and the rigidity and the correctness that Bechtel places on things.
Yeah.
But at the same time, you want to be dynamic enough to take advantage of changes and opportunities and benefits. And that was the message that I was trying to give to these people. We want to make sure the numbers are right, but look at the benefits here. Let's think about how we can get from here to here.
Sure. Yeah. So, I mean, there are a lot of places where that balance of, operational discipline, but also creativity.
Yeah.
Like balancing those two things
it's hard to do.
It's hard.
And I think we did that in CoAid during my time there. I mean, CoAid was basically, we didn't maintain a bug list because if a bug came up, we fixed it. There was the numbers that you got out of Caesar 2 and, the other things were always right. We pride ourselves on that. We were the gold standard. But at the same time, we were constantly pushing the envelope of what you could do. I developed this bidirectional interface between CADWorks, our design program, and Caesar 2. And, that was a holy grail at one point because designers and engineers envision things, model things, handle things totally differently. Everybody wanted automated conversion and transfer of data. But you couldn't because a piping designer modeled things totally different from a piping engineer. So maybe you could send it one way, but you couldn't then make changes here and send it back. Sure. It would be like translator between two languages. You send it over and then you send it back. Like I think there's always that thing about finger licking good in English, translated to Chinese, and then you put it back and it says, bite your fingers off or something like that. That's what the typical
I get it.
Data transfer between design software and engineering software was. And I thought about this problem. How can we do this? How can we do it? And I built this interface between CADWorks, or piping design program, and Caesar 2. And you could send it both ways, and it would maintain exactly what was sent over. And if something new was put in either CADWorks side or in the pipe stress side, and sent it over, it came back and looked exactly as though the original designer had done it.
Right.
So we came up with that. I put that in 96, and like 15 years later, at the time I left, it was still it was architected so well that it's still working, despite how many new versions of Caesar and CADWorks and everything came out. Then we started looking at other things, how can we push the envelope next?
Right.
And we started looking at AI. AI was different in those days, but now
more like building a model from scratch and
or things like this is okay. When I first got into pipe stress, everybody in pipe stress had been doing it for 40 years, and they knew they could look at a system and they could figure out that's going to work or not. Let's solve it. Ding. And later, when we've expanded with Caesar 2, we've expanded the pipe stress market so much that a lot of the people who'd come to our training course were saying, I got hired out of college last week. They said, you're the pipe stress guy, but you're also the this, and this. I don't have time to learn it. Just show me what buttons to push. And they didn't have that knowledge. So I started thinking, wait a minute, we shouldn't have software that's a button pusher software. We should help these guys solve things. So I started thinking about, how do you solve everything? What are the rules that you go through? What's the process? And we put that in. So we had the loop wizard. We called it, the plumber's helper, because the piping and, you've got a problem, you've got an overstress, push this button and poof, solved, and things like that. So we were constantly trying to push the envelope of what we could do, integration of graphics. We would bring the graphics model right into the engineering model, so you could see exactly where you had to work with and things like that. So we're trying to push the envelope while at the same time maintain that ultra tight rigidity of keeping everything
discipline and keeping the bugs
keep
down.
the bugs out.
Yeah.
Don't release anything too soon. Have the numbers be right.
So I wonder if this current generative AI technology inflection point that we're in will be the push that some of this niche engineering software needs to actually make the transition. Because, one thing that somebody like Caesar 2 could do if they had all that data in one place is they could do some pretty amazing things as far as...
That's the stuff that's keeping me awake these nights.
All right,
I'm lying awake saying, well, I'm looking. I'm saying, okay, the AI is a big thing. I'm investor and mentor and advisor a whole bunch of different startups. And the big thing is obviously AI. And it's getting into everything. And I just recently joined as an advisor to a AI-based startup that's creating 3D models based on AI prompt or something like that. And I'm thinking, why can't we do that with piping design, pipe stress, structural engineering, things like that? Have it build the model or quickly assess the weak points, or do the stress analysis, or do everything. Okay, we got a failure here. Well, it can put in the loop. It can rejigger the supports or something like that. And the other thing that came to me was exactly what you just said. Maybe that's the point that pushes it. Right now, CloudCalc's
the tipping point, right?
Yeah, CloudCalc's a product right now that does what the other guys do pretty much, and then has some nice bells and whistles that people should want. If we can take it really, by a factor of what up to AI, have it be AI based and have it take advantage of that. I mean, the sky's the limit here. So I'm thinking about, where does that go? What's the best way to incorporate this, and what can we do?
Yeah, what if CloudCalc was a AI stress engineer, agentic, on your team? So you could ask it questions, and it would solve the model for you.
Yeah, you could ask it questions, or it could just put its head down and work all day and knock out all sorts of work. Yeah, no, that's what I'm thinking. That let's see where we could go and how can we incorporate that.
I want to bring it back to piping.
Yes.
And pipe stress as we conclude the conversation. My question is, how can the piping industry be more innovative? What message would you give? What advice would you give to engineering companies and to software companies that serve those engineering companies?
Well, it's actually interesting. I have to say the piping industry has become innovative or something over the last couple of years. If you look at how the piping codes has changed in the last 10 to 12 years, it's shocking. It's at a warp speed compared to where it had gone the first 75 years or something like that. There's a lot of changes. It used to be when I would teach pipe stress, I'd say, here's these equations. They don't make sense, but this is what they really meant. And then they all got approximated as this and came out as here. Well, now the equations recognize, or the piping codes recognize that computers exist. And they don't really care if these things are complicated or if they're too much work for a hand calculation. So that's grown that's
just in the last
changed.
couple of years.
Yeah, it's changed immensely. And, B31J, which has changed the stress intensification factors. They used to be Markles based on one data point, and now they're very detailed. If you look at the stress equations now, they used to leave out a whole bunch of different types of stresses, and forces and moments and things because it was too much work for the engineer. Now they're all there. Anyway, so they've made great leaps. But the other thing, I got to say, you guys have always been very innovative. I remember doing a tour of your factory. You had a lot of great stuff going on. But the one thing I really remember is you were doing some pipe supports that were going to be down in the jungle in Brazil. The steel was going to corrode, and there was an issue with that. And you had these pieces of mahogany, Brazilian mahogany out of Brazilian jungle because they didn't corrode and they resisted the weather. And you were making pipe supports out of these things. Huh. And I'd never seen anything like that. I actually grabbed a couple of blocks off the ground as just to remind me of that. Innovation, I think, if we're going to look at software, we've got to do stuff like AI. We've got to do stuff like cloud. We have to do that. We can't remain in these silos forever. And in the piping, in new materials, I think people understand bellows better. For a long time, there was a fear of bellows.
Expansion joints,
when I first started, the rule was don't ever use them. And if you were going to use them, you had to go up to the chief engineer to get it okay. Sure. But now, your expansion joint segment is doing quite well.
Fastest growing part of our business.
So, people are realizing that they understand better the products that are available and let's say the materials that are available. Fiberglass pipe is understood a lot better than it was, a number of years ago. There are now piping codes for doing this, and it used to be the engineer had to do it by the seat of his pants type thing. So I can't help but think that what you talked about earlier, the balance between operational discipline and creativity, is part of the formula that these companies, whose let's acknowledge it, largely a large part of what they do is risk mitigation. That they need to find ways to embrace striking that balance. That balance. I understand the risk mitigation, but at some point they got to look at taking that big step.
Right. Right. Hey, Tom.
Hey.
Thank you so much.
Always great to spend time with you. Every time I sit down with you, I learn a lot. So it's great to be with you. So,
need to have you come out and visit the plant.
Happy to do so.